Today we're going to have a look at functions. Now, you'll have looked at functions probably since you were in primary school. Your first introduction to functions would probably have been a machine. You'd have an input, you'd put a number in, it would go through the magic machine and it would come out with a different number. That would have been your first experience of functions, and it's the same idea. We just change the way we write it so it becomes more mathematical. So instead of a box, we're writing what the function is, and instead of having to guess what that function does, we're told what that function does so that we can work out how we can change our letters or numbers. Okay, so if we have a function that multiplies by x, then it produces the value 3x. We can write this as f is the function x such that it becomes 3x, or simply f of x equals 3x. Okay, the function then hasn't changed from when you saw it as an input-output machine. It is just a rule that connects one set of numbers that go in, which we call the domain, to the range, which is the numbers that you come out. You don't need to know the words domain and range at National 5 level. If you go on to higher, then you'll learn more about them then. Okay, let's have a look at some examples then. If I've got the function f of x equals 4x minus 5. Now the f of x part tells me I've got a function, whatever that function is, in x, so my letter in the function is going to match up. So if I have f of x is 4x minus 5, and I want to find f of 5, I'm going to replace my x with 5. So I get 4 times 5 minus 5, which is 15. Try the same with negative 3. F of negative 3 is 4 lots of negative 3. Take away 5. 4 times minus 3 is minus 12. Minus 12 take away 5 is minus 17. Okay, it doesn't just need to be numbers that we use for this. We can do it with letters as well. If we want to find f of p, we still follow the same rule. I do 4 times whatever's in the bracket, take away 5. And whatever letter it is we have, we replace the x with that letter. Okay, that's called evaluating a function, when you're replacing the value of x with something else and working out what it is. Okay, let's try another one then. We've got f of x is 3x squared minus 1, and I want to find f of minus 2. That means I need to replace my x with minus 2. So I get 3 lots of minus 2 squared, take away 1. Minus 2 squared is minus 2 times by itself. Remember, a negative times a negative is positive. So negative 2 times negative 2, or negative 2 squared, would be 4. Times 3 would be 12. Take away 1 gives me 11. F of 5 will be 3 lots of 5 squared, take away 1. We always do the squared first before we multiply, because it's only that 5 that's been squared, not all of it. So we get 3 lots of 25 minus 1. 3 25s is 75. Take away 1 gives us 74. Okay, we can do this with letters and numbers combined. Function, it's just disappeared off the page there. 3x squared minus 1, that's f of x. So f of 2x means I replace x with 2x. Now 2x all squared is 4x squared. 3 fours are 12, so we get 12x squared minus 1. Third example, same idea, just slightly trickier function. This time we've got f of x is 2x cubed plus 1. So f of minus 2 is 2 lots of minus 2 cubed plus 1. Minus 2 cubed is minus 2 times minus 2 times minus 2. If I deal with the numbers first, 2 times 2 times 2 is 8. Minus 2 times minus 2 is positive. 4 times minus 2 gives us minus 8. 2 times minus 8 is minus 16. plus 1 gives us minus 15. Okay, different question for part B. This time we're told that f of x equals 55 and we need to find x. So f of x is still this function 2x cubed plus 1, but we know that that 2x cubed plus 1 is equal to 55 because that f of x is equal to 55. Solving it from here, take my 1 to the other side, it's a plus 1 to be a minus 1, so that'll be 54. Here I've got 2 lots, I just want 1 lot. 54 divided by 2 is 27. I've got x cubed, don't want x cubed, I just want x, I want the cubed root of 27. Jumped a wee bit there. Cubed root of 27, you look for a number times and by itself 3 times, it gives you 27. 3 times 3 is 9, times 3 is 27, so x must be 3. It's a typical exam question, that one. You're asked to use the function backwards, so given what the answer is, find the number, or find the value of x. Another one like that then. If f of x equals 4x minus 5, find p given that f of p equals 11. So f of p, I replace my x with p, is 4p minus 5, but it's also 11. That was a bad 5, let's try that one again. So I want to solve this part here. So we get 4p minus 5 equals 11. Here I've got a minus 5. It's going to come over and become plus 5. 11 plus 5 is 16. I've got 4 lots of p, so I want p just on its own. 16 divided by 4 is just 4. Okay, another couple of examples for you then. F of x equals 3x squared minus 1. Find p given that f of p is 26. So f of p would be 3p squared minus 1. We're told that's equal to 26. So 3p squared minus 1 is equal to 26. Got minus 1 here. So it comes over, becomes plus 1. So that would be 27. Dividing by 3 would give me 9. That gives me p squared is 9. So p here is going to be plus or minus 3, which we will come back to when we look at quadratics further. Just now, just trust me, it's been a bad example in there. Last one then. Given that f of x is 2 over root x, find f of 6. Leave your answer with a rational denominator in simplest form. This was an exam question one year, or very similar to an exam question one year, and it was in and on calculator paper. Okay, so first thing I need to do then is I want to find f of 6. To find f of 6, I want to replace x with 6. So that gives me 2 over root 6, but I want it with a rational denominator. You could have rationalised the denominator before putting the 6 in if you prefer, it makes absolutely no difference. To rationalise the denominator, I want to times by root 6 over 6. So I get 2 root 6 over 6, which simplifies down to root 6 over 3. Okay, I'll leave you to try some functions then.